So in this video, I want to show you how I put together that animated GIF on Tuesday, January 26th. I used PowerPoint to do this because the animation capabilities on PowerPoint are much better than they are on Google Slides. You can make animated GIFs on Google Slides. You need to have some kind of extension to do it, and I forget what that's called, but if you look at add-ons on uh, Google Slides, you can find it. So this is a copy of the data chart that Kate and I put together. We have December 21st for two different cities. We used Ushuaia, Argentina, and I don't have the chart in here for Quito, Ecuador, but that's the other chart that we used. I'm showing you this one to show you how I calculated the sim times. We had sunrise location and time, sunset location and time. I turned the sunset times into 24-hour times instead of just 12-hour times. And then I subtracted to get the number of daylight hours. It's not great. It's not accounting for twilight and things like that, but it was good enough for this activity. Then I took this and I counted each hour of daylight time as 0.25 seconds. And then I just sort of rounded it. So I rounded this to 17 hours of daylight, which translated into 4.25 seconds of simulation time. This on, let's see if I go to the next slide here, would be how long this little sun takes to go across the compass here. So that's where I get the sim time from. On the animation that I used to make it go across, I also included an animation that made the sun get bigger and then smaller again. I'll show you what that animation looks like in a moment. In order to do that, I had to cut the time in half, the sim run time in half. And then I decided by looking at my times that the longest simulation run was going to be 4.25 seconds. I just rounded that up to 5 seconds to get some kind of a delay on when I needed to start my simulation. So each of these arcs that the sun will take across the compass should be about 5 seconds. But depending on how much daylight hours there are, the simulation will start at different times. That's why there's a delay for each of the suns. If you want me to show you how I calculated that in Google Slides, I will. But I think what most people wanted to see was how I did the animations. So once I figured out how long each of the simulations is going to run, then I just set up my background. Uh, just found a random compass, made blocks and everything like that. Once I had it the way that I liked it, I screenshotted that and turned it into a background on all the rest of my slides. So now the stuff doesn't move around. That was kind of important when I start to work with these suns and get them moved around in different places. So once I had the background set, then it was time to plug in different boxes here for the different amount of daylight hours. And I have a different label depending on which point in time that I'm looking at. And then I have the suns put into place here. The location on the compass of each of the suns where it starts. And if let me open up the animation pane here. There we go. So like this one here, this is a path animation on PowerPoint. It takes a path from there to there. The starting point and the ending point correspond to the sunrise time. I'm sorry, sunrise location and sunset location. Approximately. It's not perfect. I didn't get that nitpicky with it, but approximately. The first thing that I had to do was get everything in place and then time the animations. If you look over here, this 0 in front of this animation means that as soon as this slide opens up, these animations start to play. And none of these animations are separate from each other. They are all together. If I wanted to make them separate, then I would have to click on an animation. And up here where it says with previous, I would change that to on click. And now it looks different. Now I have to click something to make it work. It works better with these animated GIFs if everything happens with each other. You just calculate in delays so that things happen in a sequence. And those delays is what I calculated on this last column over here. So, first thing I did was I had December solstice pop up, and along with that, I got the daylight hours for Ushuaia, the daylight hours for Quito, this sun picture, and that sun picture. But there's a delay here. Down here at the bottom, it'll show you in seconds when things are happening. I wanted that sun picture to show up, and then this path, again, that's the line going across. And this animation is when it gets, this is called grow shrink. This is when it gets bigger and then gets smaller again. Just for funsies, I'm going to pop, well, no, I'm not going to do that. Never mind. Uh, To program this to go at a certain time, you'll go into effect options. And I always set these to a smooth start and a smooth end of 0 seconds. Timing, this is where I would put in my delay. Uh, my original, yes, yes, yes. My original delay time was 0.375 seconds. That's what I calculated. PowerPoint didn't like that many decimals. So instead, let me go back in there. It defaulted to 0.4 seconds. No big deal. I mean, it's just a little animation. Duration, I calculated based off of that chart again, and I don't want this to repeat. You can. I've done some interesting GIFs where things repeat, or you put it backwards, you rewind it when it's done. But that's not what I was looking for here. So that's going to take that sun and move it in a straight path in 4.25 seconds over to its sunset time. Then we have grow shrink. This is the one, it's a little yellow star that gets big again. Again, go into effect options. Again, I change these to, it defaults to 1 second smooth start and smooth end. It makes it too choppy for me. I just default it to 0. Size, you can make it gigantic, you can make it smaller. You can't do anything you want to with that. Timing, I have the same delay. It should be 0.375. I didn't like that, so I switched it to 0.4. And the duration. Now, this one, I do want it to auto reverse. So it got big and then it got small again. That was supposed to represent like the sun, yeah, going up in the sky and then going back down towards the earth again, if you will. So this one I did want to auto reverse, which is why the timing here is only half of what the timing was on, here we go, over here on my line path. So calculated those in, calculated when the next sun should show up over here. And I did the same exact thing with the line going across Quito. Now, Quito was super easy. The reason why I didn't show you the Quito data was because Quito is really, really close to the equator. So its daylight hours hardly change. It's going to stay at about 12 hours, and it goes anywhere from 6 minutes to 8 minutes of daylight hours. Which means that the time going across stays exactly the same. There wasn't anything I had to do to the keto side except for shifting the sun up and down where it needed to go. So effect options over here. This is for the path going across. I had a delay of 1 second, a duration of 3 seconds. And then for the grow and shrink picture again, that was smooth start, smooth end, auto reverse, a delay of 1 second, and a duration of 1.5 seconds. Then I wanted everything to disappear before I went to my next slide. Uh, so this just shows all the different pictures disappearing at the correct times going down. So let me present this slide so you can see what it looks like all on its own. Actually, I don't think you can see that because it's on the other side of my screen. Tell you what, instead of that, let me hit play all. There we go. Okay, that was one slide. Now, I do the exact same thing with my next slide. I have to adjust the suns a little bit. I change out the daylight hours to correspond with the actual daylight for each of these dates. I adjust the delay times. This time, my delay time is only 0.5 seconds and the duration is 4 seconds. I get that again from this chart. So here's my January 21st. I calculated a delay time of 0.5 seconds and an entire sim run time of 4 seconds. That's where I get those numbers for January 21st. Same thing. I'll hit play all so you can see what it does. I really encourage anyone who is interested in learning this stuff to watch some videos on how to do animations on PowerPoint. There are so many amazing things you can do with this. So there's January, February, March, April, etc., all the way on through. Each date has its own individual slide until we get down to November. And that's where the animation finishes. Now, to turn this into a GIF, the first thing that you want to do is to hide any slides that you don't want to have shown. So I don't want this data table shown in my GIF, so I'm going to hide that slide. Hide slide. I don't want my original background. This is the one where I set everything up. I don't want that one in my animation, so I'm going to hide that slide too. Then, when you go to save this, you want to save a copy. uh, save it wherever. In my version of PowerPoint, and I don't know what year it is, but it is newer than PowerPoint 2016. I have PowerPoint 2016 on my school computers. That version does not have this option right here, animated GIF. Whatever version I have here, which is newer than 2016, does. So you'll need to find that right there. Click it, save it as whatever, and save the thing. And when you do that, you end up, whoops, there we go. You end up with that GIF that I showed you, or that I was showing in class today. I have used this process to make all different kinds of animated GIFs. I think I said in class that I've used this to make an example of light stretching in Redshift. I have used this to explain Hubble's law, Kepler's laws, basically anything that it's hard to draw. It's too abstract to draw on paper to make kids understand. You kind of have to see it in motion. I've used this kind of process to do it. So that is how I made my GIFs. Yeah, I don't know what else to say. That's it. Thank you.